Once again, let's have a quick recap about test for casein. Biuret test is performed. It turned out to be positive. Found out to be positive. Then isoelectric precipitation. Take 3 ml of test solution, add 2 drops of bromocresol green or BCG indicator and mix. Add 1% acetic acid drop by drop until a green color is obtained, which indicate pH is close to 4.6. A Kerdi precipitate is formed. Casein may be present. Casein is precipitated at its isoelectric pH, which is 4.6. Newman's test. To 5 ml of test solution, add 0.5 ml 40% NaOH, heat strongly, cool under tap water, add 0.5 ml of concentrated HNO3, filter the precipitate to the filtrate, add a pinch of ammonium molybdate and warm gently. Newman's test is for casein. Canary yellow precipitate is formed, presence of casein. Casein is a phosphate protein. How to perform Newman's test? Take the solution, add 40% NaOH, heat it to 5 ml of test solution, add 0.5 ml of 40% NaOH, heat strongly and cool under tap water, add 0.5 ml concentrated HNO3. Filter the precipitate to the filtrate, add a pinch of ammonium molybdate and warm gently. Don't forget to add ammonium molybdate. What is the result? Canary yellow precipitate. Once again, to the solution, 5 ml solution, add 0.5 ml of 40% NaOH, heat it strongly, then cool it. After that, add 0.5 ml of concentrated HNO3 nitric acid, filter the precipitate and the filtrate, add a pinch of ammonium molybdate and warm gently. Ammonium molybdate and warm gently. Then precipitation by neutral salts. Take 2 ml of test solution, add equal volume of saturated ammonium sulfate solution, mix and allowed to stand for 5 minutes. Ammonium sulfate. White precipitate is obtained. Presence of casein. Casein is precipitated by half saturation with ammonium sulfate. Then sulfur test. To 2 ml of test solution, add equal volume of 40% sodium hydroxide and boil for a minute. To 2 ml of test solution, add equal volume of 40% sodium hydroxide and boil for 2 ml of test solution, add equal volume of 40% sodium hydroxide and boil for a minute. Cool and add 2 to 3 drops of lead acetate. Mix it well. No brown precipitate is obtained. Presence of casein. Casein does not contain sulfur containing amino acids. Identification of unknown protein sample. First we will be taking that unknown solution. Then Biuret test is performed. Violet color protein confirmed. Then isoelectric precipitation. Kerdi precipitate may be casein. Test for organic phosphate, canary yellow color precipitate, casein. Molish test. Sulfur test with original protein solution. Then no precipitate, other proteins. Heat and acetic acid test. Coagulation may be albumin. No coagulation, gelatin or peptone. Ammonium sulfate saturation test. Half saturation and Biuret test with filtrate, violet color albumin. Molish and sulfur test with original protein solution. Full saturation with Biuret test with filtrate, no violet color. Full saturation with ammonium sulfate and Biuret test with filtrate, no violet color, gelatin, violet color, peptone. Identification of unknown protein sample. First we performed Biuret test to confirm the presence of protein. That means to 1 ml sample solution, add 1 ml of Biuret reagent and mix. Presence of violet color protein confirmed. Isoelectric precipitation. To 3 ml of solution, add 3 drops of bromocresol indicator. Add 1% CH3COOH drop by drop until a green color is obtained. No precipitate. That means casein. Protein other than casein is present. Albumin to a greater extent. Protein other than casein is present. Heat and acetic acid test. Take 10 ml of sample solution. Hold the test tube in a flame in a standing position and boil the upper part of the solution. Lower part serves as a control. Ideal drops and acetic acid is added. A cloudy white precipitate in the heated position. Presence of albumin. Half saturation with ammonium sulfate. To 3 ml of sample solution, add equal volume of saturated sodium sulfate solution. Mix and allow to stand for 4 minutes. Filter the performed Biuret with filtration. violet color, presence of albumin. Full saturation with NH4 SO3. To 3 ml of sample, add solid ammonium sulfate with mixing, filtrate with performed Biuret test. Molish test. Reactions of non-protein nitrogenous sample. Reactions of non-protein nitrogenous sample. With reference to biological fluids, this term is used to conclude all nitrogenous substances other than proteins. The important compounds under this category are urea, uric acid, creatinine, and creatine. Other nitrogenous substances of biological interest are amino acids, ammonia, and small peptides. Test for uric acid. Murexide test. When uric acid is treated with concentrated HNO3, it undergoes oxidation. The immiscible ring is cleaved and the derivative condenses to give purpuric acid. When uric acid is treated with concentrated nitric acid, it undergoes oxidation. The immiscible ring is cleaved and the derivative condenses to give purpuric acid. The ammonium salt of purpuric acid, also called murexide, is purplish red in color. The ammonium salt of purpuric acid, also called murexide, is purplish red in color. Materials required: uric acid solution, concentrated nitric acid, dilute NH3. 4 to 5 drops of concentrated nitric acid is added to 5 ml of sample solution taken in a china dish. It is then evaporated over a low flame carefully. A red residue is formed. This dish is allowed to cool. Then add 1 to 2 drops of dilute ammonia. Observation: purplish red color is formed. Color disappear on warming. Presence of uric acid. Murexide test once again. Materials required: uric acid solution, concentrated nitric acid, and dilute NH3. 4 to 5 drops of concentrated nitric acid is added to 5 ml of sample solution taken in a china dish. It is then evaporated over a long flame carefully. Red precipitate is formed. The dish is allowed to cool. Then add 1 to 2 drops of dilute ammonia. Purplish red color is formed. Color disappear on warming. This is a very simple test, murexide test. Just take the uric acid sample, add some drops of 4 to 5 drops of concentrated nitric acid, then warm it. After that, warming or evaporation will be taking place. Then a red residue is formed. Then the dish is allowed to cool. Then add 1 to 2 drops of dilute ammonia. If ammonia is not available, just don't perform that. We will get red color. Purplish red color is formed. Color disappear on warming. Presence of uric acid. Then test for creatinine. Jaffe test principle. Creatinine react with alkaline picrate in the presence of NaOH to form orange colored complex of creatinine picrate. Janowski complex. Materials required: creatinine solution, saturated picric acid, 10% NaOH. Don't forget this 10% NaOH. Procedure. Label the 2 test tubes, T for test and C for control. In the test, take 2 ml of creatinine solution, add 2 ml of saturated picric acid solution and add 1 ml of 10% NaOH. In control, take 2 ml of water, add 2 ml of saturated picric acid solution, add 1 ml of 10% NaOH. Observation: orange color with creatinine in test, yellow color with water in control. Presence of creatinine, 10% NaOH. So that's all about this general scheme. Once again, I need to just quickly scan about these 2 tests. Test for uric acid, murexide test. Uric acid is treated with concentrated HNO3, undergoes oxidation and the immiscible ring is cleaved. And the derivative: when uric acid is treated with concentrated nitric acid. Test for uric acid, murexide test. When uric acid is treated with concentrated HNO3, it undergoes oxidation. The immiscible ring is cleaved and the derivative is condensed to give purpuric acid. The ammonium salt of purpuric acid, also called murexide, is purplish red in color. Materials required: uric acid solution, concentrated nitric acid, dilute NH3. 4 to 5 drops of concentrated HNO3 is added to 5 ml of sample solution. Taken in a china dish, it is then evaporated over a long flame carefully. 4 to 5 drops of concentrated HNO3 is added to 5 ml of sample solution. Taken in a china dish, it is then evaporated over a low flame carefully. A red rusk is formed. The dish is allowed to cool and then add 1 to 2 drops of dilute ammonia. Purplish red color is formed. Color disappear in warming. Presence of uric acid. Concentrated HNO3 is added. Heating. Evaporate. That's it. Test for creatinine. Jaffe test. Principle. Jaffe test. Principle. Creatinine reacts with alkaline picrate in the presence of NaOH to form orange colored complex of creatinine picrate. That is the Janowski complex. Creatinine solution, saturated picric acid, 10% NaOH. What is the formation of the creatinine? React with alkaline picrate in the presence of NaOH to form orange colored complex of creatinine picrate. That is the Janowski complex. Janowski. Label the test tube T for test tube and C for control. Then take 2 ml of creatinine solution, add 2 ml of saturated picric acid solution, add 1 ml of 10% NaOH. In control, take 1 ml of water, add 2 ml of saturated picric acid solution, add 1 ml of 10% NaOH. Orange color with creatinine test, yellow color with water and control. General scheme for the identification of unknown carbohydrate, protein and non-protein nitrogenous substances. Unknown solution by Urette test. Violet color, protein present. Follow the scheme for the identification of proteins. No violet color may be due to carbohydrate or non-protein nitrogenous substance. Molish test. Reddish violet ring, carbohydrate is present. Follow the scheme for the identification of carbohydrate. No reddish violet ring may be a non-protein nitrogenous substance present. Sodium hypobromite test. No effervescence, creatinine, uric acid. Effervescence may be urea. Specific urease test. Pink color, urea. No effervescence, creatinine, uric acid. Phosphotungstic acid reduction. Blue color, uric acid. No color, creatinine. Schiff test, black deposit, uric acid. Mirexide test, purplish red color, uric acid. Jaffe test, orange color, creatinine.